Okay, so my hope is that you tried these two problems and you looked them up in the back of the book, and hopefully you got the right answer. We're just going to take it one more step. We're going to try to find the area of a region. Well, the important thing to understand is finding the area is really just, the area is the integral, right? So really what you want to do is you want to integrate this region. And if we were to draw it, well, we have the line x equals 3 here, and the x-axis, so we have the x-axis, which is this. We have the line x equals 3, which is this. And then we have the graph, whatever that graph looks like. So I don't know exactly what it looks like, but presumably it probably looks something like, I don't know, something like this, maybe? And then there's an area underneath it that we can find the area. So that's what we're working on in this problem. All right, so we're finding the area of this region. We know that the area of the region is really just the integral. So what we want to do is, I guess we should graph this function before we really are too certain. So let's pull a graphing calculator out. Take a look at what this thing looks like. Graphing calculator here. So it's x over, oops, it's x over x squared plus 1. We'll just pause this while we wait for this thing to load. Okay, so we were trying to get an accurate graph of this so we could just be certain that we had a good integral set up. So it's x over x squared plus 1. So x over x squared plus 1. And I like to, oops, that's there. X squared plus 1, good. All right, so that's the graph. So if we look at a normal Windows Zoom 6, we can see that my interpretation wasn't really right, but could have been worse, I guess. So if we set our window from, I guess, -1, let's try to move this, actually. So sometimes you have to spend a little bit of time working on the window, getting it to where it needs to be. So this blue line is a lot more like what the graph would look like. So let's pull that down there and use that for our reference. It'd be great if we had known how to graph that, but my skills just weren't that sharp today. So this is something more like what I've got, and this is 1, 2, 3, 4, 5. So here, so this is really what we want to integrate. We want to integrate from 0, that's where it starts, to 5. And really, we just want to integrate the function from 0 to 5. So what we suspected is the case that we just need to integrate the function from 0 to 5. But it's good to know that. I think what you could have probably done is realize that if you set the top equal to 0, your x equal to 0 is going to give you 0, and that's why we're going to intersect right here at the origin. So at the end of the day, we're trying to find this area, and our tool for finding that area is the integral. So we're just trying to integrate this. So let's just take that to a new page. A little cluttered here. Integral from 0 to 5 of x over x squared plus 1 dx. All right. So ignoring everything else, now just trying to solve this integral, let's think about what of these is the function, what is the derivative. So either this is your function or this is your function. And I'm going to say the bottom is your function, it's an x squared. And then the derivative would be 2x. So we get x squared plus 1. Our du is going to be 2x dx. If you think about it, you don't really want that 2 here because there's no 2 in this function right here. So I'm going to divide that 2 out. Kind of a common thing for us to understand now. And now we just want to rewrite our integral for a u substitution. So we're integrating from 0 to 5, but those are actually x values, so I'm not going to even write them right now. So I'm going to leave these blank. I have the 1/2 for my du over 2, and I have du over u, I guess, is really what it is. Because if you think about it, the x dx is kind of on the top, and x squared plus 1 is kind of on the bottom. Now what we need to do is just know that du over u integrates to ln of the absolute value of u. Piece of cake. So we have 1/2 ln of the absolute value of u plus c. Problem is, we still haven't really done this because 1, we have a u in there, and 2, we need to plug in these values, these x values. X equals something, x equals something. So first of all, we know that we can change this to ln of the absolute value of, what was our u? It was x squared plus 1. And we want to evaluate that, and when I have something bigger, I like to put big brackets, and we want to evaluate that from 0 to 5. So this is an x value, and this is an x value. So now we're just going to plug in 5, plug in 0, subtract the results. We would normally, so this is just maybe for a second, you normally have seen me do a straight bar here, like this, from 5 to 0. That's when it's really a simple function. When I get confused and I want to like make sure I group everything clearly, I put big brackets. So I put big brackets. I do not put the squiggly s integral sign. Big brackets. So let's work on this. At the end of the day, it's 1/2 ln of 5 squared is 25, so this is going to be ln of 26 minus 1/2 ln of the absolute value of 1, I guess. So that's what really is happening here. So I have an ln of 26 over 2 minus, not equals, minus. And this is ln of 1. ln of 1 is equal to what? That's a big question. So we know that e to the 0 is equal to 1. And that should be really in our brains at this point in time. If we know e to the 0 is 1, we can reverse it to say that ln of 1 is equal to 0. So this is equal to 0. This whole term is equal to 0. So really our answer is ln of 26 over 2. And that is actually the area under the curve. How can we check that? Well, first we could type in ln of 26 and divide it by 2. So let's try that. So I'll go back to my calculator. I'll type in ln of 26, and then I'll divide that by 2. And I get 1.629. So 1.629 is what I think is the answer. And now the way we could probably check that we integrated correctly is we can go to Math 9. We could type in the, so 1.629, we'll come back to that. Having some trouble here with the screen. Okay, cool. So we got a 0 there, we got a 5 there. We're integrating, I think we were integrating just, let's go back to the top. X over x squared plus 1, x over x squared plus 1. So really we just need to do x divided by x squared plus 1. I think I've done that correctly with respect to x. And, oh, look at that. We get the same answer, 1.629. So we know that we've integrated it correctly by hand, and that is pretty exciting, actually. So let's see how much time we got on this video. Probably a good place to stop. And I guess I'll go easy on you guys today. So just those 2 videos, the notes on that. And I guess maybe, no, you're not going to try that. So yeah, just work on that for today, and we'll catch back up in class. So just the 2 videos and the 2 examples. All right, catch you soon.